In this tutorial, we will discuss the Mockito framework, focusing on how to write unit tests for your application using Mockito and how it is utilized in real-world scenarios. Before diving into the Mockito framework, it's important to understand why unit test cases are necessary. Firstly, we write test cases to ensure all functionalities are working correctly. For example, imagine a scenario where a colleague wrote an API but didn't test it before deployment. As a result, some functionalities didn't work as expected. Issues such as incorrect screen alignment or a search button returning a null field might occur. Deploying an application without testing can lead to such problems. To prevent these issues, we write test cases. It also simplifies the work for other developers who can easily understand the exact API requirements and responses by looking at the test cases.
So if any issue is found, it can be easily debugged and fixed, right? Now, let's discuss the Mockito framework. Why do we need the Mockito framework and what are its advantages? In every web application, there's typically a three-tier architecture: the controller, the service, and the repository. When writing test cases using traditional approaches without Mockito, if you write a test case for the controller, it will first hit the controller method, then go to the service, and finally to the repository. Imagine if we are hitting the database multiple times for testing. That's not a good idea. This is where Mockito comes into play. Mockito allows us to mock the service or repository data. When a request comes to the controller, it is forwarded to the service, and instead of going to the repository and hitting the database, it mocks the data. This mock data acts as the database, preventing unnecessary database hits during testing. That's the essence of the Mockito framework. Now let's see this in action. I have already created a database application with CRUD features in Eclipse. Let me show you the controller. I've implemented 4 methods, one for saving a user, another for retrieving all users, one for finding users by address, and a method for removing a user. The structure follows a 3-layer architecture with a controller, service, and repository. I'm using MongoDB, so the repository extends from the Mongo repository interface. In this example, we'll write test cases for our user service and mock the data from our repository. This means we won't need to interact with the actual database. Instead of retrieving real data from the DB, we'll mock the data and return it to our service. All right. Let's start writing the test cases now. But before we begin, this is my test class, annotated with @runwith and @Spring Boot test. Now, let's inject the service and repository. We'll declare private user service for the service and similarly inject the repository as private user repository. We need to mock the repository, so we'll annotate it with @mockbean. Since we're writing test cases for the service, we'll inject it using @auto-wired. Now, let's write the test cases one by one. In the user service, we have 4 methods: add user, get user by address, and delete user. Let me start by writing the test case for getUser method so you can see how Mockito works. I'll create a method called public void getUserTest. In Mockito, there's a predefined static method, when, which we'll use to mock the behavior when repository.findAll method is called. Then we'll return the mocked value, which will be a list of records. What does this mean? When the method is called, it will return the specified list of data instead of accessing the actual database. That's why we mock the repository. Now, we can use assert equals to compare the expected and actual results. The find all method will return a list of records. So, what we can do here is compare the size of the list. We'll call service.getUsers, which returns the list of users, and then simply compare the size of that list. This method will call the repository, and the mocked data we've specified will be returned. We are then comparing the expected result with the actual result obtained by invoking the service. To test this method, annotate it with @test. Now, let's run it. I'll minimize the code for clarity. If you check the JUnit tab, you'll see a green indicator, meaning our test case has executed successfully. Now, we want to confirm whether it's actually hitting the database. Let me show you. I already have 5 records in the database. However, in this test, we're just using hard-coded data. We're using some dummy data, meaning I've mocked the data. Now, let's move to the controller, or better yet, the service. In the service, it will call repository.findAll method, which should return the 5 records available in my database. I'll add a print statement here to say, getting data from DB. Alright, we'll check what data is being returned, whether it's the actual user data from the database or the mocked data specified in our test. Now let's run it one more time. The test case was successful. Now let's check the console. You can see the output, getting data from DB along with the mocked data, 376, Daniel, 31, and USA. This indicates that we are only receiving the mocked data, not accessing the actual database. That's why we mock the repository. Now let's quickly write the test case for the other methods. I'll zoom in and start with the second method. Find users by address. So, public void. Let's create the getUsersByAddress test. First, we need to provide an address such as Bangalore. Now, I'll write the method. When I call repository.findByAddress, it should return a list of users. There might be multiple users associated with a single address, so we'll retrieve the list from this method. Let's use a single object for testing purposes. Now, we'll write the assert equals as we expect to get only one object from the database since this is our mocked data. Therefore, our expected value is 1. Now, let's call service.findUsersByAddress method, which will return the list of data. Now, let's get the size of the list. Since we expect to receive one mocked data entry, we'll compare it with the expected value of 1. That's why this method is annotated with @test. Similarly, write for the save method, okay. Right here, public void save user test. Let's create a user object. Let's create a new user object, user equals new user. We'll set the fields to something like Pranaya for the name, 999 for the ID, and Pune for the location. Additionally, we'll change the age to 33. Now, let's use the when method. When repository.saveUser, then return user. This means when I call repository.saveUser, it should return the user object. If we check the service, you'll see that the first action is to add the user. I'm simply going to save the user and return the same user that I just saved. That's why in the when method, when I call repository.saveUser, it will return the user object, since the return type of this save method is the entity. Now let's compare this using assert equals. So the expected value is the user object that I'm going to save, while the actual value will be what we receive from our service call to add user. Okay, so annotated this one at the rate test. Similarly, we have another method for deletion. Let's write the test for the delete method. Public void delete user test. Now, let's create a user object. We'll start with the delete method. Public void delete user test. This method simply deletes the user from our database and does not return any value. Since it's a void method, we need to approach the test case differently. We'll use Mockito's do nothing. Let's create the user object that we intend to delete using the same user we just added. We're going to delete this user for testing purposes. Now, we can call the service's deleteUser method and provide the request. Since this method returns void, we can't expect any return value or use assertions to compare results. Instead, we can verify whether our method was called. So, let's verify the mocked data. Our mock is the repository, and we need to verify whether it was called exactly once. There's a method called times that allows you to specify the number of times a method should be invoked. I'm going to set it to 1, and then we'll check if the delete method from the repository was called. Now annotate this one at the rate test. We've already tested the get method. Now, let's test the 3 remaining methods. I'll minimize the code, and then we can run the tests. Yes, let's go to the JUnit tab and expand it. I'll zoom in for clarity. We can see that all 4 test cases have passed successfully, indicated by the green marks. Now, in the second test, we added a user with ID 900. Let's check the database to see if the same user object was inserted. Okay, the object was not inserted, which highlights the usefulness of Mockito. This allows our test application to avoid interacting with the actual database. Instead of retrieving real data, we are simply mocking the data here. This is our mock data. That concludes this particular video.